Hi everyone, I'm in the person of Kelvin, a level 300 student from Accra Technical University, and you are welcome to my electronics modeling project. In this video, I'll show you how I was able to design a complete Arduino Uno board using KiCad, from the very first schematic all the way to 3D render of the final PCB. Let's jump in. Alright, I started building the schematic in the schematic editor using the KiCad. I placed the main component first, such as the Atmega 328P microcontroller, the 16 MHz crystal oscillator, the voltage regulator, and all the necessary passive components like resistors and capacitors for decoupling. I wired everything according to the official Arduino Uno reference design, making sure to label all the power rules and net names clearly. I also added the ISP header on the USB to serial converter. Here's it. Once I finished the connection, I ran the electrical, also known as the ERC, to catch any missing pins or wiring errors, and made sure everything was passed. And to my surprise, at first I had some errors. I was able to debug all those errors, and when I ran my ERC, I'm not getting any errors. So as you can see here, after I ran my ERC, there is no error, there is no warnings. Now I'll walk you through how I was able to assign all these components with their corresponding footprint and assignment. So when I come to tools, I'll locate assign footprint here. With the schematic confirmed, the next step was assigning the footprint. KiCad's footprint assignment to let me link each schematic symbol to a raw physical package. For example, I assigned the Atmega to its corresponding footprints. That is the SMD crystal package, the through-hole connectors for the pin headers. I double-checked each footprint against the datasheet to make sure the pin pitches and part sizes were correct. This step is crucial. If this footprint is wrong, this PCB won't match the raw component. So when assigning your footprint, you should make sure that you assign the correct footprint to the correct component. Now, what you see here is the routing. For the routing, I imported the net list into the PCB editor, placed the components in a logical layout, and I also kept the crystal close to the microcontroller supply section near the input jack, right here. I then started routing the traces. So here, the red wires that you see, or the red routing that you see, is showing that it is on top of the board, and then for the blue ones shows that the routing is at the back of the board. I also made sure that to keep the analog and digital ground separated, and used wire traces for power lines to handle high currents. Because if you check this wire and this wire, you will realize that one is taken just to indicate that that one is for the power line that's going to the power supply. After routing, I ran the DIC, also known as the design rule check, to fix any clearance or trace weight violations. Once the routing is complete, finally the best part, that is the 3D view. So you head towards to view, give it a click. You click on the 3D viewer to as well, and here comes our Arduino Uno. You can see the USB port, the power jack, the headers, the SMD components, the Atmega, the sockets too as well, where you can put your jumper wires. And here you also get the back view of it. Here shows the back view, and this shows the front view too as well. And that's it. I believe I've showed you a complete Uno, right from the schematic to the 3D visualization. Feel free to drop any question in the comment section, and also follow and like this video for more. Peace. I'm out.